Okay, so now let's look at determine if the series converges or diverges. So we're given this problem, we're using the integral test right now. So we want to check for our three things: positive, continuous, and decreasing. So we're going to let a sub n equal f of x equal 1 over x squared plus 1. X squared plus 1 is positive, so we're positive. 4, and we only care about the numbers bigger than or equal to this value right here. So for x greater than or equal to 1. Continuous, we had n squared plus 1 earlier. X squared plus 1 is not going to have any holes or asymptotes in it, so we know that it's continuous. And our last one, decreasing. If we take the derivative of this, u prime is 0 times x squared plus 1 minus 2x times 1 divided by x squared plus 1 squared. We're only plugging in positive x values, so because we have a negative 2x on the top and the denominator is always going to be positive, we are always going to be less than 0, so f prime of x is less than 0 for x greater than or equal to 1, so decreasing. For x greater than or equal to 1. Okay, now we can actually do our improper integral. So we have the integral from 1 to infinity of 1 over x squared plus 1. We're going to change it so we have the limit as b approaches infinity of the integral of 1 to b of 1 over x squared plus 1. And now we're going to do all of this fun stuff. So we have the limit as b goes towards infinity. If we look at what we have x squared plus 1, or x squared plus 1 squared. This right here is tangent inverse, so we have the limit as b approaches infinity of tangent inverse of x from 1 to b. Now we're going to go ahead and plug in our values, so the limit as b approaches infinity of tangent inverse of b minus tangent inverse of 1. Okay, so now we're going to look at, as we approach infinity, tangent inverse is the angle that we're looking at. So when we think about what we're doing, tangent inverse of 1 is the same thing as saying tangent of theta is equal to 1. So what angle would we need in order for a tangent of theta to equal 1? Well, that happens at 2 places on our unit circle, so we generally go with the first place. That would be pi over 4. When we're at pi over 4, our tangent is equal to 1. When we're looking at the tangent graph, we get something that looks like this a bunch. So when we look at tangent inverse, we end up getting something that looks like this. And these same places where we would have asymptotes that are vertical, we now have asymptotes that are horizontal. So as we go towards infinity, we're going towards that asymptote that we would have had, which is going to happen at pi over 2. So we have pi over 2 minus pi over 4, which means pi over 4 is our answer, which tells us we are converging. And because this converges, we know the series converges.